record. Perfect. Okay, so we are recording here. Let's get questions going. Sorry if you hear dogs and or ambulances going. I did survive the haunted hotel because I'm here now, if you believe this is the real Kyle. I did not get haunted or poltergeist, I guess. So it's pretty great. Okay, not bad. All right, let's get started. All right, well, I hope everyone's doing great. Hope everyone enjoyed their break. We got a few, there we go. We got a few days off, so hopefully we use that to start our assignments and everything, and everyone's feeling comfortable with Java. As of today, I don't believe we have any announcements. I don't have any. The new exercise videos out there. And also don't forget the studio reviews are out there too that go through exactly what the studio was like, at least the way I approached it. So if you ever do have any questions about that, or of course want to look back on lecture, all those are posted. I left that link in the video channel on Slack. So continuing on, I was asked a really good question last time that I've just been pondering nonstop by one of the TAs. And that question was, does null take up space? And I wanted just to get lecture started off here with just answering that question. Don't think this is a big thing. You don't really need to know this. It was just a really cool question. And I really just wanted to share the answer with everybody because I was not able to answer it back in the past lecture. So does null take up space? Well, before we answer that, let's go ahead and just look at string that's set to null, my string, equals null, and an integer that's set to my number, or that's called my number, and it's set to null. In this example, we're not going to ever have a primitive that's set to null because primitives can't be set to null. Only objects can, or classes, things with capital letters like string and integer. So what is null? Let's answer that first. Null is the absence of a value. It is nothing. It's a black hole. It is no value. It's a white piece of paper. I have no idea any other analogies for nothing. It's nothing. So null is nothing. I don't have a string for you. I don't have an integer for you, so I'm going to set you to null. So let's explain what happens when we set something to null, more at a memory level. So let's go back to our memory neighborhood. Remember, memories are just like houses. We have to put data somewhere. So if I set my string to null, it goes into the first house, and the house is just set to null, which is, again, nothing. But nothing has to be something in computers, so we have to store it. We have to store nothing somewhere. So null is stored at this address. Now what happens if we also assign integer, my number, to null? Well, that points at the same exact house, the same exact location. Nothing is only stored once inside of our computer, inside of our application, our memory neighborhood. So this house here, one house houses all the different variables that have null in them. So every variable that's ever set to null points to one house, one address, which only takes up like 8 to 16 bits from what I found online. So to answer that question, does null take up space? The answer is yes, but not that much. It's very, very light. So that is that. Any questions about that? Again, not a very important topic to cover. Null's a good thing to know, but knowing that it's not like storing anything is not the biggest deal.
What if you saved like a million things to null? Would it still only be 8 to 16 bytes? Because would it have to have an attachment to those addresses somehow, or?
Technically, yeah. You assigning a variable or creating a variable will also take up a little bit of space. So a million things set to null is going to be bigger than 18 to 16 bits, but your value will always be 18 to 16 bits. But the allocate or the connection between those million variables that you just created and that one null still takes up space. Those million variables take up, oh gosh. Now you're asking me a better question. Now I have to go look up this. I don't know how much a variable takes up, but it takes up a very minuscule amount of room. So it's going to have a space, but it's not going to be that significant. Good question. Dang it. Now I have to look up that. Okay, I'm writing that down.
I just think there's probably some kind of cheat in there. You know what I mean? Like, do something cool with that.
I'm sure you can. Yeah, that'd be a cool project. See what you can do. Don't crash your computer though. I feel like you're going evil scientist on me. Don't do it yet.
Someone else.
Awesome. All right. Okay, so I see a question here. If all null variables have the same address, can you use equal equal to compare? That's also a really good question. Let's take a look. String a equals null. String. Yeah, I would assume yes. A equals B. Anybody want to make bets? Not with money because that's terrible, but brownie point bets? Anybody? I'm going to say yes.
No.
Oh, true. Okay, good. The theory stays. Awesome. I mean, of course it's true. I knew that. Yeah.
Would that also work with the dot equals?
I believe so but yeah, let's see. I believe so because dot equals default is to compare. Oh, I'm sorry. No. Can I resolve? Oh, equals. Let me see. Yeah, I'm going crazy. There we go. I believe it will still be true because equals by the default action of it will compare the memory addresses. But oh, that's right. Yeah. It's pointing to a null.
That's what I thought, but I just wanted to see it in action.
Yeah. And the fact is actually it will break. I don't know why I thought it would work. No, it's a null pointer exception. When we set a string to null here, we basically tell it that it's not pointing to a string class, it's pointing to a black hole, nothing. That means all of our helper functions, aka equals, is no more. It doesn't exist.
But both those strings are pointing to a black hole, so it should be equal, right?
They are both pointing to a black hole, but remember dot equals, the thing that we're using here, this tool, no longer exists. We cannot use dot equals on something that's equal to null. Dot equals no longer exists. However, we can still use those double equals to compare.
That's okay. I thought the whole purpose of dot equals was to equate strings, but it doesn't work in that instance.
You are right in both cases. It's to evaluate strings, but null is not a string. Null is a black hole out in deep space. So dot equals doesn't exist. So you are right. It does use to compare strings, but we have to make sure our strings are not equal to null. Otherwise, that dot equals.
Oh, okay. So it doesn't work if it works if they're both like actual things.
Right, exactly. If they're both actually strings or they're both integers. Yeah, exactly.
Okay.
Cool. All right, don't want to take too much time on this, so I love all the questions. If you have any more, feel free to direct message me and we can talk about it. Happy to talk about this fun stuff. Okay, let's move on. Let's start class. We're going to start with some deja vu. We're going to go back to things that we should know, but maybe we just need a quick refresher. So I would just like confirmation about what exactly am I looking at? Is it a class variable? Is it a constructor? Or is it a method? Who can tell me what we're looking at? Say that again.
Class variable.
Class variable.
Very good. Class variable. And how we can identify it's a class variable is because it says private. Class variables are typically private. It has a data type, int, integer. And then it starts with a lowercase letter, my dog's age. These are all properties of a class variable. Awesome job. Moving on. How about this? What is this called?
Method.
Method, very good. And we know it's a method because it says public and then has a data type, a return type, which is void, and then starts with a lowercase letter. But the biggest thing about methods is the parentheses. We know it's a method from a mile away because it has those parentheses. So yes, you are absolutely right. It is a method. Let's keep going. You guys are doing great. How about this? What is this called?
Method.
Very good. It's a method. Yes, because it has those telltale signs of a parentheses. Awesome. Yes. Let's keep going. You guys are doing great for today. How about this? What is this?
Constructor.
Constructor.
Very good. It's a constructor. We know it's constructor because it looks like a method, but it's missing one big thing. It's missing the return type. It doesn't have a return type here. Another telltale sign, it has the name of the class. And Matt, I think you're about to say that, so I'm sorry I cut you off.
Yeah, that's what I was about to say.
Very good. Yeah, it has the name of the class, which in this case would be dog, which is a capital D. So you're absolutely right. This is a constructor. All right, keep it going. What is this?
Method.
Method.
That's a whole new object right there.
Scanner.
Whole new scanner object.
You're
No, I'm sorry, a method. Yeah, it's a
Method.
Method.
So you are all very close. You saw those telltale signs of the parentheses, but this is
What about
technically
new?
a call to the constructor.
Mm-hmm.
Scanner is a constructor. New in front of it is calling to that scanner to create a new instance. So what this is here is the constructor for scanner. How we can also tell, because it has that capital S, methods don't start with capital letters. They start with lowercase letters. Constructors start with a capital letter. This is going to call to our constructor in our scanner class. The thing we just saw in the last example, pretending that dog is actually scanner, is going to call to this. So any questions surrounding that?
So you said that it's a constructor because it has new in front of it. It's a capital letter, and
Those
it calls
parentheses.
the parentheses.
Mhm.
What did I say? I said something different. I'm sorry.
No, I'm just adding to your list. No, you are absolutely correct in everything else.
Okay, so those four things is a telltale sign that this is a constructor.
Very good. If you're playing I Spy and you see something like this, all those attributes you just said, that's going to be a constructor. All right.
And it must have, I'm sorry, it must have
Yeah.
the semicolon behind it as well.
In this one, because we're calling to it, we're creating a new instance of the scanner. So yes, this would be typically the end of the line. So we put a semicolon there. Now, if you were to create a constructor, we wouldn't put a semicolon here. This is creating the constructor. So this is creating the constructor, and this is calling to the constructor. I know it's a little tricky, but remember, if we create something, we have to call to it, right? Everything we've ever created in all of our applications, we've always called to it in some form. We've called to methods, we've called to class variables. Now we have to call to constructors, and this is how we do it. And this will look more familiar when we just add something to it. So who can tell me what the first part is? And hopefully no one saw that small little glimpse. What's this left-hand side called?
It's a.
Which part? The private part?
The left-hand side, yes. Left-hand side of the equal sign. What is that called?
It is a class variable.
Declaration.
Very good. It's a declaration, but it's also a class variable. It's a declaration of a property. It's a class variable. All of these words are very much synonymous. So yes, it is a property. It's a class variable. So we take that class variable, my scanner, and we call to the new scanner, the constructor, to make a new instance and save it into our container, which is my scanner. That's with everything at work there. So we're putting all of our stuff into work here on this one line. Any questions about this? All right, I wonder if I have any more. Oh, I do. Cool. What is this?
Pronounce
Method.
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 Very good. It's a method. Awesome. That was my last one. Sometimes when I was going through this back in whatever the old days, I was like perplexed. I was like, oh, that totally is a method. I just never like put two and two together there. So calling it out, this is also a method. All right, that's all I got. So hopefully everyone's awake now. Everybody awake? Everybody good? Yeah, everybody talkative? All right. I'll take that. It's Thursday, guys. Tomorrow it's like Friday Junior right now. Everyone should be so stoked. All right. Let's move on.
I love that.
I stole that from someone. Unfortunately, I'm not that creative, but I love using it.
For some reason, when you think of that, I can't stop thinking of the relationship between Nick and Nick Jr.
They're kind of related. All right, so let's move on to properties. So we're going to go back to the old days, basically basically a week and a half ago to when we were talking about classes for the first time. We're going to go back to our dog. We're creating our dog class here. How do we know it's a class? Because of that very clear keyword there that says class. And then it starts with a capital D, which all classes do. As we always remember, what are our 3 portions to when we're creating a class? Our 3 areas. What's the first one? Always at the top.
The class variable.
Very good. Very good. Class variables, properties. What's the next thing?
The constructor.
Constructors.
Fantastic. And what's the third one?
Methods.
Methods. Sweet. All right. Getting into this. What if I wanted to create a class variable for the dog's name called my dog's name? How would I do that? Someone tell me how to declare that.
You would put an access modifier on there and make it to private. And then you would just put the variable name. And I mean, you can just really close it off right there unless you want to initialize it.
Very good. So we'll start with the first word. What's the first word to start creating this variable? What would be the word I would start with for a class variable?
Private.
Private. Very good. Then what's going to be the next word in our variable?
String.
String, because my dog's name is going to be a string. And then finally, we said it's going to be my dog's name. So you're very right. It's private string my dog's name. Awesome. Moving on. What if we wanted to create the dog's age called my dog's age?
Private int my dog's name.
My dog's age.
Very good. Yep, I heard it. Private int my dog's age. Awesome job, everybody. All right, so let's move on to this new, well, not really new word. We've done it before, static. We're going to create a static variable here. Now, if I want to create a static variable for my dog's taxonomy, how would I start this one?
Private or public static.
Very good. Public. Yes. Static class variables are public. Awesome call out. Okay, so we have public. What's the next word? I think you already said it. Yeah, public static. Yep, public static, and then what?
Whatever the variable name is, dog taxonomy.
So taxonomy is going to be what kind of data type?
Oh, I mean, it's going to be a string.
Very good. Awesome job, everybody. So it'd be public static string taxonomy. And then I had to look it up what actually a dog's taxonomy was, but it's Canis. Canis, I guess. I'm not good at Latin. Never took Latin. But this is a dog's taxonomy. So we use that static keyword here to create this dog taxonomy variable. Because no matter how many dogs I create, if I create a Shih Tzu, a Husky, and a Lab, their taxonomies are always the same. So I don't need to make this an instance variable, something that's customizable. Instead, I can create it static, so no matter what dog you are, oh, I'm getting feedback here. Okay, there we go. So no matter what dog you are, you always have the same taxonomy. Sorry, I really beat in that last point there. I was getting a little bit of feedback. Okay, and the other thing to call out is that it's public. We don't create accessors, getters or setters for public for static variables. Therefore, we create them as public, so we can access them through the classes very simply by just saying .taxonomy on top of a dog. We'll see that a little bit into that here in a second. So from this, any questions about this?
Could you repeat the last thing you said about the getter and setters?
Yeah, and I think it'd be better if I showed you. So we're gonna go into IntelliJ here. We go up to our dog. This is everything we've done last time. And what I'm going to do is create that public static taxonomy that we just did. So I say public static string taxonomy, and then equals Canis. There we go. And sometimes I'll put a line between my public statics and my privates just so I can see them when I look up here. Okay, so what did I mean by we don't put getters and setters here? Well, we don't use getters and setters for static class variables. We use them for our private class variables that are not static. So the question is, okay, then how do I access it? How do I change it, Kyle? Why aren't you telling me this? Well, I will. Calm down, Kyle. I'll tell you right now. What we do is that we go to where we defined our dog, which I defined. I forgot exactly where we did that. Do it over here. This looks cleaner. We're going to create that dog variable. Or we're going to create dog here. And what I want is just get the taxonomy out of the dog. Well, it's static. And if something is static, a method or a variable, how we access it is not by creating an instance of the dog, but by calling the dog directly. And then I say taxonomy. This is how we access a static class variable. So if I ran this, I get back Canis. This, again, is how we access static only class variables. And we can do this because we set this to public. We set taxonomy to public. If I were to set it to private, IntelliJ would get very angry at me because we can't access it. We set it to private. That's why we always need to make sure our static variables, our static class variables, are public. All right, leaving it open to everyone. Any questions about this?
But in order for you to access that, you have to have it in your main. Is that correct?
In order to access it? Oh no, main, I'm just putting it there as an example. You can put this anywhere. I can put it down here in my method too if I wanted to. Remember, main is nothing but a starting point. That is it.
Okay.
It's where we call our first code. So I say sc.myMethod, and I really hope I'm not going to print out a bunch of stuff here. I forgot what we did last time. That's so long. Yeah, and then we still get Canis. So we don't have to call it from the main. Again, and that main is just a starting point.
Okay, thank you.
Yeah, absolutely. All right, any other questions? All right, well then let's move on. So we got static down. Now let's have, static variables can still change though. But can my dog's taxonomy ever change? No, dogs are always gonna be Canis. Again, no matter what kind of dog you have, it's always gonna be Canis. So I don't want my taxonomy to change. I want it to stay constant, never change. And so how we do this is we use that fantastic keyword called final. Final does not allow our variables to change if it's in that declaration. So if it says public static final, that means I want to keep the static class variable constant, never to be changed. Hopefully I drilled in how important final is, and I guess basically it's normal functionality, so it just doesn't change. So that being said, a question that might be going through your mind exactly is that, okay, I can set my static class variables to final, but can I set my private class variables to final? Such as, what if I wanted my dog's name to be final? And the answer is yes. What we do is we put private final string my dog's name equal to start, or whatever you wanted your dog's name to be. A big thing to point out, remember that this is just public because it's a static class variable, and this one is private because it's a instance variable, one of those properties. So take a very close look at this before we implement it. Any questions about this?
Yes, would you repeat what you said about instance variable between those two? You said one was something because of something, and then you said this one, the private final, was because it's an instance variable.
Absolutely. The top one is public because it is static. because it is static. It's only public because it's static. Static variables are public. The one below it doesn't have the word static in it. Therefore, it's not static, and we have to set it to private.
Okay, thank you.
Yeah, absolutely.
Can you explain the difference between static and final? From what I understood is that you can't change the value of both of them. Is that correct?
Let me double check that.
That's if something statically typed, not the static keyword.
What did you say? Sorry.
If something is statically typed, like Java statically typed, then you can't change the data type. But with this, they're just saying that it's a different meaning of the word static.
The final is a different meaning of the word static?
No, the static that you're thinking about in public static final, that static is different than, it sounded like if you were talking about something like, for example, Java is statically typed, so you can't change the data type once you already created it. Is that what you're talking about?
Mm-hmm. I think in the book, I was confused because they were going over static and final. And to me, it sounded like both were similar.
So how about this? Let's talk about just those differences between static and final. Focusing only on static right now. Static, if something's set to static, it has to be accessed directly through the class. Directly through the class. Dog.taxonomy. That's the magic of static. Is that if you set something to static, this is how we have to access it now. So does that, at that point, make sense?
Yes.
Okay, so that again is the magic of static. Let's move on to final. Final is completely separate from static. They have no entanglements. Final means I want it to be constant. I never want this variable to change once I set it for the first time.
Okay.
If we static, again, you don't have to have static and final together ever. They can be independent of each other. They don't have any relationship with each other. They both have magic to them. Static has that magic to directly access things through classes, while final has the magic to make variables never change once they're set.
Okay. And if something is static, can you change something about it?
Absolutely. So that's what I did in this example here. Dog.taxonomy, when we first set it, was canvas, canis. And now I set it to changed here. So when we ran this, we got changed. So you can absolutely reset statics. Remember, final, the keyword final is the only thing that has that magic to let it never be changed. So awesome question. I'm happy we got to separate those a little bit more. Chris, thanks for helping out as well. All right, so let's implement these final things. I'm losing track of the slides here. Okay, so real quick, we're gonna come in here and we're going to set, like we said, our taxonomy can never change. So I'm gonna put final in here. Once I put final in here, we're getting a problem because like I said, I changed this to changed. Once I set it to final, I can't do this. It can never be changed. So I'm gonna comment this out. So now this taxonomy can never be changed anywhere in the code ever. So it will always be Canis, which is what I want because I don't ever want my data to change. I don't want it to be like Wikipedia and be able to be edited. I want this to be constant, true knowledge that I know will never change no matter who touches my code. And that's what that final keyword does. So before we move on, again, open it up for any questions. Becca, I see that you're typing. Or did you want to ask that question?
Yeah, I was just wondering, you mentioned that static is non-customizable. And so that's why I was getting confused between the difference in static and final. But is that just, it's non-customizable between different objects that you make? So it has the same value for each object versus it's the same value no matter what, ever and ever.
Right, exactly. Yeah, I'm sorry. Yeah, what I meant by customizable is that if I create 3 dogs, again, that Shih Tzu, Husky, and Lab, I can't change taxonomy between those three classes. They can't be customized between those instances.
Mhm.
It can
But it
only
can
ever
still-
be. Go
But
ahead.
it can still be changed if it needs to be changed in total.
Yes, absolutely.
Okay, awesome. Thank you.
Yeah, for sure. All right. Any other questions? Cool. See how we're doing on time. Awesome. All right. Now let's move on to this final string dog's name that we were just talking about. Once I name my dog, that dog's name's not going to change. I want it to stay consistent. But I don't know what I'm going to name my dog until I pass it into the constructor. So a question you might be asking yourself is that, okay, if I set these things to final in my dog, do I have to set them here in line, or can I set them, again, allowing them to be customizable? And the answer is yes. What we can do is that we can set my final only one time. That's an important thing. You can only set it one time. So you can either set it in line at the class variable level where we did Canis, or we can set it inside of the constructor. You get to pick from these two locations. If you choose in line here, you know exactly what it's always going to be. It's basically hard coding it, kind of like taxonomy, always to Canis. But again, we're setting our dog's name to final here. And I know every dog in the world is not going to be named the same thing. So I want to make sure that this is, again, customizable to my class instances. So I'm going to say final here. And, you can initialize. Where do you not initialize? Oh, this is last name. Oops. My dog's name is here. There we go. There we go. So I set my dog's first name to final. Let me just put that up there. So I set it to final, and so when a value is passed into our constructor, it gets set to that dog's name. Now we got that warning when I did this on the final on the last name, because what it's saying is that variable my dog's last name might not have been initialized. What this warning or what this error is saying is that in one of my constructors, I'm not setting my dog's last name. Remember, when you set something to final, it can only be set something to, or it can only be set to a value once, but it must be set at least once. You can't just have it roaming around. So it's a very strict keyword as well. If you set something to final, it has to be set either in the constructor or in line. So this is a really big rule to really try to get across. So I just want to see if there's any questions about that.
So if you leave it blank, then there's nothing you can do about it. It's just going to be blank forever if it's final.
Exactly. You can leave it blank, but you have to initialize it to blank if you want it to be blank. So you have to set equal to empty quotes. And yes, it will always be blank. Yeah, great question. So choose wisely when you're setting it.
I'm still confused on that, what you just said about leaving it blank.
So blank as in an empty string. This dot my dog's last name. Say I want to set it to blank down here. It's a string. So blank is essentially empty strings.
Mm-hmm.
So this would be setting it to blank in essence. So that's what you're referring to.
But you have private final. I thought as long as you have final there, you cannot change it.
Exactly. Very good. But where I have final up here, I never set it to anything. If I don't set it in line up here, I have to set it in the constructor.
Okay.
And that's where I set it. I set it here in my constructor. And remember, we overloaded these constructors, so I set it in multiple places. But we can only always call one constructor. So that's kind of how it works there.
Okay.
Cool. Great questions, everybody.
So if you can customize static values, what's the difference? Why do you need to use static? So what's the difference between public string dog versus public static string dog?
So static class variables would be if it doesn't change depending on how many instances of a class you build. I use static here as an example because a dog's taxonomy, what the dog is, will never change no matter what I name the dog. When I create a dog, I have to give it a name. Depending on how many dog instances you have, you're going to have a different name for each of them. but the taxonomy will always stay the same. When something stays the same throughout classes, no matter how you create it, that's a hint that it should be static.
Okay.
Yeah, and this one is a little tricky to kind of, it takes a second to figure out when we should use static and when we should not use static. Odds are you're probably not going to be using static. You're going to most likely be using these the instance variables, these properties or class variables here, not the static form of them.
Okay.
So yeah, take a mental note on that, is that most of the time you're not using static. But if you see something that stays consistent and never really changes or is hard-coded in there, that might be an indicator that it might be static and or it might be final.
Okay, got it. Thank you.
Yeah, we start doing a lot of stuff with polymorphism and stuff.
Oh, don't even say that word yet. Can't even say that word yet. That's not allowed yet. Oh, gosh. That word, he never said anything. I'm going to edit that out of this lecture. Oh, I can't wait for that. It's going to be fun. Polymorphism always reminds me of like Yu-Gi-Oh cards. All right.
I have one question.
Yeah, please.
Can you please define the inline and inside method for final? I didn't get that one.
For sure. Inline would be up here.
Mm-hmm.
I set it equal to Canis. Another inline would be, say, I set this always to start. Inline means I'm hard coding something in there. I always want my dog's taxonomy to Canis. I always want my dog's name to be Stark.
Okay.
So that's the inline approach. The second option you get with finals is to do them inside of the constructor, to offer more of a custom, again, that keyword apparently of the day, customizable approach to setting your finals. I don't always want my dog's name to be Stark. I want to give people freedom to create a dog however they want, if they want to call it Frodo or whatever. That's why I don't hard code it inline. I assign it in the constructor. So that would be the difference. Hard coding inline, like you see up here, and then assigning it in the constructor is down here in the constructor. Again, only for those final class variables.
Okay. Thank you.
Yeah, absolutely. All right. So big remember, final variables can only be assigned once. Biggest thing, so make your decisions wisely when you're setting them. All right, let's keep going. So you're probably asking yourself right now, or probably wanting to ask yourself, but maybe don't want to ask it because you don't want to get this any more confusing. Can methods and classes be final? And the answer is yes, but with a caveat. We do not need to worry about this, so don't worry about it just yet. Just put in the back of your minds that final can exist on classes and they can exist on methods. And that is all I'm going to say about that. Any questions about that? Awesome. All right. Everybody ready? Let's start with some questions. Static class variables or properties are private.
False.
True or false? Yes or no?
False.
Awesome. False. They are public. They should always be public or we can't access them. Final variables can be assigned from the constructor. True or false?
True.
Very good. True. You guys are doing great. All right. You can only use final on non-static variables.
False.
Right. We can use them anywhere. We can use them on whatever we want. Classes can have multiple constructors.
True.
True.
What is that called? Bonus points.
Overloading.
Very good. The double equals does not compare values.
False.
False.
I think it's true.
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 Yes,
True. It's true. They don't compare values. They compare what?
Memory references.
Memory references, memory locations. Where do each of these things we're comparing live at? Where are their homes? Yes, not necessarily the values. All right. Now I'm going to open it a little bit more to everybody. Ask a question or answer one. Please type as any questions you have about this. We just covered some very in-depth material. And if you didn't have the time to type because you're listening, please ask those questions now. I want to hear everything everyone has about those statics, those finals, anything else that we talked about. I want to try to minimize as much confusion as possible. If you don't have a question, then tell me, in the Matrix, does Neo take the blue pill or the red pill?
Let's see how deep this rabbit hole goes.
Yeah, exactly.
Red.
I think
Red.
take the blue.
Blue.
Oh, I'm hearing some blues. I'm hearing some reds.
Blue pill. You stay in one.
Oh.
Yeah, you take.
He takes both.
He takes the red pill, everybody. The red pill.
Yes.
Catch up on. If you're gonna work in tech, you gotta be in the Matrix. You gotta catch up on it. I'm just kidding. I had no idea. I had to look it up. Oh gosh. All right. Again, send me those. Even if you don't want to ask it on the questions thing, please send a direct message. I'm happy to answer as many questions as possible. Just giving you guys here a quick mental break before we move on. In that case, speaking of mental breaks, in Finding Nemo, what address does Dory continuously repeat?
Oh.
E. Sherman.
It's like 14 something.
42 Wallaby Way.
Yeah. Wallaby Way up the street.
Sydney.
I like it. We got all the parts here. So small thing on this one. If anyone's ever played Jackbox Trivia Murder Party, I won the game on this question, so I had to put in here. I was so happy. So yes, it is P. Sherman, 42 Wallaby Way, Sydney.
That game has gotten me through quarantine.
Oh, same here. I have invested lots of money in all of their boxes. All right, cool. Great, guys. So now that we have our mental breakdown, let's move on to some fun things, some special methods. We have the .toString, which we've seen before in this dot equals. These are nothing new, but today we're going to start maybe not liking them as much, or maybe liking them more. We're going to explore them. Looking at toString first, we're going to talk about just converting something to a string. Maybe just a simple integer like this called myInt class. Now, if I wanted to convert this to a string and also print it out, I would say myInt class dot toString. And then I use that system.out.println to print to the string. Nothing crazy, we've seen this. It prints out 5. Let's move on. I say int, my primitive int equals 5. And then I print this out. My question to you is, what would this print out?
I don't think toString would
Something weird.
It'd probably be a null. No, it wouldn't. It just wouldn't print it because it's not an object.
I love it. Sorry, that was kind of a trick question. I hate trick questions, and I came out of my mouth as a trick question. The answer is it would be an error. We would not even be able to write .toString on the end of my primitive int because.
Which error would that be?
It would just be like this does not exist on a primitive error kind of thing.
Okay.
Yeah, it wouldn't be a compilation error. It wouldn't be like a null pointer exception or something like that. It would literally just be Java would highlight it in red, or IntelliJ would highlight red saying you're asking the impossible.
Right.
Because toString methods and dot equals and all these other helper methods only exist on classes, class objects, non-primitives, like integer, string, scanner, not lowercase int, not char, anything like that. Those are primitives, and toString doesn't exist on that.
Good call.
We cannot call toString on primitives. So let's keep diving into this. Let's dive into the rabbit hole even more. Taking that red pill. Dog. My dog equals new dog. Stark, and his age is going to be 5. I print this out. What's going to be printed out?
Stark. Oh.
Yeah, just Stark.
The answer is something really weird.
That's what I was thinking. Yep.
Yes. It's going to sometimes have a bracket in there, or dog, an @ sign, and then a bunch of numbers. This technically right here is its memory address, what it is. The machine understands it, but this is definitely not human readable. So by default, prints that memory address. Only Java can really understand. But Java is not us. I like things human readable. As a human, I'm slightly biased. So how can we exactly change toString to do this? Let's take a little bit closer look at that.
We gotta be
right.
right.
That was a rhetorical one. Okay. But I like the enthusiasm. I might ask a question here in a second. All right, so we're gonna have that class dog there, and we're just gonna assume these class variables that we're gonna be using in this example are just are assigned at the top. They're just not pictured. Disclaimer. So, Chris, I think you had an answer possibly. How would we hijack this toString method?
Okay, so you would do like I guess dog. It wouldn't be. Yeah, it would be dog. Yeah, I'm sorry. Public string, toString, and then I guess in the actual block of code. No, I'm sorry. In the actual argument, you would put. Yeah, I'm gonna just let you guys get that one.
No worries, no worries. So we have this method, and how we hijack it, how we tell the compiler, disregard what Java does as a default. I'm coming in here with my rules. I want to make it my way. How we say that is with this @ override. This thing helps the compiler know you want to change the behavior of this special method, the toString method. So this is how we hijack toString to do what we want it to do. In this case, I want to return something more human readable. In this case, my dog's name is this.mydog'sname. That's how we do this in Java. That's how we hijack a toString method. We just hacked our first method. Hope everyone feels like a total boss right now. So let's take a closer look at that actually in code. We'll stay in our dog class. And down here is typically I put all of my overridden methods at the very bottom of all of my methods. So I'm going to do that here. So I'm going to do exactly what we did in our example. Override with a capital O. And then public string, because toString naturally returns a string, toString. And then I have to return a string from here. I said I was going to call it I forgot exactly what it was. My dog's name is : plus this.mydog'sname. And there we go. We just customized this toString method to do what we want. But does it work? That's the question. Corey, great question. I'll get to that in 1 second. So we have our dog nowhere here. Let's create a dog. I don't create a dog at all. Dog, my dog, dog. Start. Not string. It's been a long day apparently. Start. And I said 7. All right. And now what we're gonna do is system.out.println, and then my dog.toString. And let's run this. I'm gonna comment out that too. Running. And there we go. We just printed out this. But my question is, or maybe you were asking, okay, what if we just didn't put that override in there? Or what if we just took that all out? What would it actually have printed in the first place? Well, good question, Kyle. You should have done that first. All right, there it is. This is what that memory address looks like. So if you wanted to see a real witness of it, that's what it looks like. But again, I don't really like that. I like to actually be able to read my values. So that is what that is. So there's a question out there that's asking, what does this @ exactly mean? Well, that is a fantastic question. This, and I'm mad I didn't put that in my slides, is that it's called an annotation. Think @ annotation. If you ever see any words for annotations, they're referring to these things that go on the top of methods or on the top of classes. Annotations, annotations. It's gonna be a very big keyword going into the future. So when we want to annotate a function or method like this, such specifically if we want to override it, we use @ that annotation, then the word override. Let's see what happens if we take out override. Technically, it works. Let's see. Yeah, technically it works. Yeah, you don't have to. I mean, it will still work because you created this method inside of the class. However, not getting into what the future holds, if you don't put those annotations there and you're trying to override something, it's going to cause headache in the future. So take my word for it. Add those annotations. Yes, that's all I'm going to say. Add those annotations. Yeah, just please take my word for it. Oops, no, I wanted. Essentially, just giving a really tech overview that if you're overriding those methods that have to do with inheritance, again, you're going to use in words, don't actually listen to this. If you don't override things that are being passed down to like your classes that are being created here, you're going to get huge headaches if something ever tries to inherit from the classes that you're building. So that might not make the most sense right now, but it will in the future. So I promise, just add those annotations.
For line,
yeah.
sorry, line 47, for when you set it to toString parentheses, can't it be any other name? Why is toString special?
ToString is a special method because it exists on all objects. Objects have very specific helper functions or helper methods that every object always has. You've seen on all of your objects, if you call .toString, it exists. If you call .equals, it exists. You might see .hashcode. All of these are special methods, AKA at the bare basics, these methods exist on all classes. So that being said, I guess, tell me a little bit more about your question.
So I'm trying to understand. So if you just do public string dog's name parentheses, wouldn't it return the same thing when you call it?
Tell me how would that be depicted? So you said return what?
So on line 47, instead of toString, say like toName parentheses, and then
absolutely.
call it.
Yes, so you could absolutely do that too.
So I think I'm trying to understand why toString is special in this case.
So toString is special because toString is like the star of Hollywood. ToString exists. Everybody knows about ToString. Every single class you'll ever create, from scanner to integer to dog, will know about ToString.
Okay.
If you ask it about toName, it'll have no idea who you're talking about, because toName, when we created here, was very just specific to dog.
Okay. So
right.
Are you saying that once we create a toString to be specific something, that we can use that throughout the whole?
We can use it specifically for that class that we customized it for.
Okay.
So,
okay.
Yeah. Yep, everybody knows about toString. So we customize that famous toString just in our dog class to how we want it to act.
Okay.
Why wouldn't we just come up with a different standard rather than overriding one that already exists?
Well, so then we'd be just creating another standard when one already exists. So my question to you would be, what standard would you want to implement to take out the current one?
I mean, anything other than toString. It could be print this or whatever. Yeah.
Yeah, absolutely. And you can definitely do that. You could completely just call to print out dog's first name or something, and print out the last name, and you can customize it to that. ToString there, this is just kind of a very simplistic, fun example. But ToString, again, if I just called it on dog, just returns that memory address. If I needed to return JSON data or some big payload that compiles all of my data into something, I want to hijack that ToString method to essentially not return me the memory location, but something more precious to me. Again, you could always just create another method that says, do this or do that, or print out this, print out that. But if you only have one thing you need to print out, and it's technically converting your class into a string representation, that's what ToString was named for. ToString. Convert my dog to a string. So by naming convention, you typically want to use that toString method. So to fairly answer your question, it all goes onto the developer at the very end of it. If they really don't think the toString method is worth hijacking to do what it needs to do, then you can absolutely create a method that says to other string or something like that. This is one common practice that you'll want to do as a developer to save space in code and make things more simplistic and set to the Java standard so other developers can understand it. Like that common language kind of. So not a really good answer for that one. I do apologize. It just boils down to this is the Java standard and this is what the Java gods said kind of thing. I can look up more examples too, Adam, and I'll get back to you and see if there's any way better I can explain that. Because I would love it explained better to me.
You can if you want. It's not that big of a deal. I'm just curious more than anything.
Yeah, for sure. Okay. Lisa, I see that you're typing. What is your question, or unless you about to press enter?
If we wanted two different strings, then would we just make one the toString and another one a different method?
Absolutely. Okay. Right on the money. Hence would bring in Adam's suggestion is that if you need it in two different forms, then you're going to have to create two different methods. toString is not going to do what you need to do.
Are we going to be putting toString in just like in every class like a constructor? Is that going to be commonplace or good practice?
Not necessarily. Constructor is always commonplace. toString is if you need it. So if maybe instructions ask you to convert some, I don't know, student scores or names to of a student class to something that's human readable, hint, hint, maybe a string or a toString method would be acceptable. Or like a job, I forgot, it's jobs actually. If a job object maybe needed to be converted into something human readable, a toString method would be really useful. Things like that. Ooh, so, yeah, I completely lost my place here. Anything else on this toString in this annotation?
I have one question. Inside the book in 5.3.1, there is written like you can call toString just by, calling like when you initialize a variable and just call that person or that specific variable. Not, you don't need to like put person.toString method.
If you can send me that example directly to me, I would be happy to take a look at it.
Yeah, sure.
Okay, so I know we're getting out of time and we have one big thing we have to go over still. So I'm going to move on, but I'm going to take a look at that example and get back to you and also see what we can do about that question.
Okay.
So we're going to move on. So we had toString. That's a special method. Again, it just converts our object into a string representation. We're going to take a look at something else now, which is equals, and see what it does. All right. So looking at equals, we have our integer. Again, my int class equal to 5. And I print this out. Is it going to print out true or false?
False.
This
well,
will
it's gonna be an error because it's oh, never mind. I mean, it's gonna be false.
No, well, remember, dot equals on these data types actually compare values, not memory locations. So my value of my integer is 5, as well as I'm passing in 5 to the equals. So this is actually going to return me true.
Mm-hmm.
Remember, dot equals compares values on these, on only non-primitive data types. Looking at my primitive int equal to 5, just like what we saw in string, what's going to happen here?
False.
That's false.
That's the error.
That's the error.
Exactly. Very good. Nope, we can still not do this. Awesome. All right, so let's keep going. Say we have our dog again. We have it Stark. And now I have my same dog equal to Stark as well. What happens if I do this?
True.
Yeah, that's calling for identical.
Yes.
So yeah, that's calling for the identical. So that's gonna be false. That's gonna be false because it's pointing to different location.
Dogs.
Oh, it's
They
pointing to
not
the object.
same don't mean they're the same dog.
I like what I just heard there. It's going to point to false because these values of these objects, these two dogs, are memory locations. They're stored in two different memory locations. Therefore, they're not going to be equal. Their values are not equal. Again, those memory locations. So by default, when we're comparing two of our custom objects that we created, these custom classes, dog, it's going to print out false because it's going to compare those memory addresses by default.
Yeah, that's one thing that kind of makes it easier for me. Dot equal is calling for identical equality, and the two equal signs is just looking for equality.
Looking for exact memory locations, yes.
Right.
Two equal signs mean exact memory locations. Very good. So looking at our dot equals again, assume those class variables are assumed at the top. We're going to hijack our equals method once again. So what do we do to hijack it? What's the first thing we do at the very top of the method? What do we put?
Right.
The @ sign.
Override.
And we do
At
override.
Very good. @ sign override, and then we type in our equation. And oh my gosh. It's always like that. What are you talking about? All right. I had string in there instead of Boolean. Okay, so we have our public Boolean equals, and then we take in an object, obj. All right, well, this is, okay, now everything's gonna be off just a by a bit, but we're gonna be looking at object there. What the heck is object? Where is this coming from? We haven't seen this in any of the work or the lectures that we've been talking about. So let's just quickly talk about what object is. Okay, so object, we've heard the term object all over the place, but now it's gleaming us in the eyes as a data type. So what is the definition of object? And that was a hard one because what it is just the most generic or general data type you can possibly have in Java. Every class that you will ever see in the world in Java stems from the object class. It's like we came from wherever we feel like we came from, and now we're here, lineage kind of thing. It is the starting of all that is Java objects, is this object class. Now, I might be getting a little bit too overwhelmed by this because I'm really, really excited about objects and everything. So let's talk a little bit about something more plain and simple. Let's just talk about mammals. I've been talking about dogs enough. Dog's a mammal, other things a mammal, people are mammals, cats are mammals. Mammal means a lot of different things. It means, again, people, cats, dogs. That's the same with objects. Objects is just a general data type that can represent dogs, integers, scanners. The object class is always at the very top, and everything else that we'll ever work with in Java, that's a class, stems from the object class. So this means that object, if something's passed in as an object, it can be anything. So that might be just a little bit much, possibly, because I did get a little happy and overwhelmed there because I love talking about objects. So any questions about that in particular?
Yeah, can you go over that one more time?
So,
absolutely. So say I want you to give me food. Well, you can give me cake, you can give me ice cream, you can give me salad. I'm asking for food. That's exactly what's happening here in that object parameter. If it's asking for an object, it's saying, okay, you can hand me a dog object, you can hand me an integer object, you can hand me a scanner object. So the essence to take out of all of this is that if you see object in the parameter, like you do up here with obj, it means you can pass in basically anything into this parameter. So anything can be coming your way. If you're looking for an integer, a scanner could come your way if you type in object.obj. So what it says is that you can hand me anything into this parameter. That's the bare basics of it.
Okay, thank you.
Absolutely. And we'll see more about this as we move through this equals example. Okay. Now, everybody sit down. This is the one I really want to talk to you about. Equals can get a little tricky The first thing you'll see in most common equals methods is this line. If obj equals this, return true. What in the heck is this? Let's dive into it. Who can tell me what the two double equal signs do again?
It strictly equals
Their
something.
exact location.
Location.
Exact memory location. If two different variables exist at the same exact memory location, what does that mean?
Same thing.
They're the exact same thing. Very good. Breaking that down a little bit, remember we're in our neighborhood and we have my dog that we create as a new dog class. That's going to be saved in our first address of our memory neighborhood. So if I write this line, my dog dot equals my dog, naturally we know that they're equal, but what is it doing behind the scenes? Well, it's comparing them. Equals equals, are they the same object? Are they at the same address? If they are, all of the properties will always be the same. It's the same dog. Stark will be Stark. 7 will be 7. Every one of its properties will be the exact same. So we know it's the same object. We know it's equal right off the bat. That's why we always put that there first. Now, thinking about that, any questions about that in particular? Sorry if I caused a headache to anybody.
So objects is pretty much equal to almost everything, isn't it?
Object can be anything. Yeah, it's like the Pokemon Ditto. If anyone plays Pokemon, it's like Ditto, can transform into anything. That's the way to think about it. Well, for me. Okay, well, if there's no question there, I'm going to move on. Next thing we need to ask, okay, where's the dot? Eric, can you explain what dot you're looking for? Eric?
I think he's talking about the method.
Okay, yeah. So there's not going to be any dots here. We're literally just comparing. Oh, sorry. OBJ is going to spit out. So what it's doing there is that it's literally, when you just put OBJ there equal this, what it's doing is comparing the two classes. OBJ is a class, the object class, and this is the instance of the class we're currently in. So we don't actually need a dot. That's another confusing part about that line. Worst case scenario, if this line is really tripping you up, take a step back, understand kind of the bare basics of it, but don't let it frighten you. It's not that big of a deal.
Double checking it. Thank you.
Yeah, absolutely. So yeah, take a breather if you don't understand that line. The world's not falling, or the sky's not falling, you're completely fine. Instance if it's all lowercase. Yeah, an instance is typically all lowercase. If you can elaborate a little bit on that, maybe I can get more context. Oh, I think it is instance of, yeah. I'll double check myself real quick, but yeah. Yeah, it's all lowercase. Yeah, so this is all lowercase. We'll see that in the example here we're about to do. So what is this line saying exactly? Well, one, you've already pointed out, instance of. It's asking if OBJ, the object that can be anything, it's Ditto from Pokemon coming into our method, is it an instance of dog? Are you under that blanket of object, underneath that, are you actually a dog? And it's checking that. So we have to check if object is actually a dog, and that's how we do it. Is it an instance of dog? So we put the class we want to check it with to the right side of that. Dog is capital, so it's calling the class to compare it to. So one more thing to note that you probably noticed is this exclamation point here. Why the heck do we see this exclamation point here? And real quick, this exclamation point here is when a developer is just feeling a little bit lazy. It just means the same as object instance of dog equals false. Essentially, it's just shorthanding that equals false part. That's what that exclamation point means. So I just want to make sure that that's clear. All right, on to the next part. we need to now, okay, so now that we're down here in the next part of the line of the equal sign, we know it's a dog because it got past that second if statement. It checked if it's a dog, and if it wasn't a dog, it would have returned by now. So by this third line, now we know it's a dog. But we can't get my dog's name out of an object. Java's gonna get you all confused, like, why? I don't know what object is. You gotta tell me what it is. And how we do that is some more magic. This is all about magic today. What we need to do is cast our object, that obj, into a dog instance. Casting is a way of transforming your ditto, your object, into what you want it to be. In this case, a dog. You can only transform it after you've checked to make sure it actually is a dog. So that's what we need to do next. And how we cast something, so we say dog, lowercase dog, equals the class type I want to cast it to, in this case, again, dog, and then obj, what I actually want to cast. That in particular, in the parentheses, is what is called casting. Okay, everyone take a deep breath, I know. Okay, one more thing. Once we have done those 3 major lines of confusion, now we're able to actually check to see if our dogs are equal. How we've done that is things we've seen before. So it doesn't matter, or it doesn't, of course it matters, but this part should be more self-explanatory. If I just want to check if my dog's names are equal, I just say dog, that newly casted dog object that I did above, dot my dog's name dot equals, and then I say this dot my dog's name. And then if they're both equal, we of course return true. Otherwise, we need to return false because the names aren't equal. Therefore, these are not the same dogs. I don't know whose dog this is. Get out of here. Return false. So again, I know that was a lot. So we're going to take one more close look at it. Oh gosh, I had a string in here too. That's what I get for copying slides. There we go. All right. So the first thing, this guy who probably has made everyone stop talking to me. I understand if you're angry at me, but this is that one that's checking those references to see if they're the same object. Remember, if they're the same object, all the properties will be the same. Therefore, we can return true immediately. It checks the memory addresses. The next thing we do is that we check, is this object that's coming in, that can be anything, an instance of a dog? If it's not, which is depicted by that exclamation point, we return false. So we have to check the type of the object. The third thing we do now that we know it's a dog and it's not the same object, we have to cast it into a dog object so we can actually look at its properties. So we cast that object into a dog instance. And then we can get to the fun part, the part that we're happy about. We can actually check to see if that dog's name is equal to whatever instance of dog I'm in, their name. If they're both equal, we return true. Otherwise, if they're not, the names aren't equal, we can return false. Note on that if statement there, that the one all the way down that's comparing the names, if you want to tack on more things like, okay, what if my dog's name and my dog's age have to match? Well, then you just add more into that conditional. So that right there is the equals method. So let's implement that real quick. Wow, no one's talking to me. I think I really did just anger everybody, and I'm so sorry. All right, take a close look at what I'm about to do here. I typed in the @ sign. See, I'll show you the shortcut. Maybe you'll be happier with me if I show you the shortcut. You type in the @ sign, and then it says override / implement methods. If I double click this one, it brings up a box of all these special properties, things that we've seen before. We see that toString, or well, we don't see the toString because we implemented it. We see hash code and we see equals. I'm gonna select equals and press OK. And it built it for me.
Nice.
There we go. See, are we friends again? Kinda, maybe?
Yeah.
Oh, okay, I'll take it. I'll take it. Cool. All right, now I'm all flustered now. All right, so going back to business, what's the first thing we do in our equals method? What are we gonna type? What's that first line? Who can tell me? That one that.
Object.
What is it?
Object equal to this.
J equal.
Very good. And what do we return if they're equal?
True.
Why do we return true, and what are we checking here?
Memory address.
Memory addresses. Very good. Very good. All right. What's the next line that we do?
If not object instance of dog, or not whatever you have.
Very good. Yeah, this, and also just to show you, and I promise, same exact thing. If I just want to take out that equal sign, put equal equal false here, I can do that. And then I return false. I can do either way. Again, just lazy programmers, aka me, I like to put that exclamation point there just to depict that, save me a few characters. All right, what's the third thing we do?
To check the dog instance, or cast object.
Very good. We cast it. Very, very good. So we say dog equals parentheses, dog. Oh, OBJ. So now we're casting that object into a dog. All right. Now what's next?
If my dog's name, dot equals this my dog's name.
Very good. We return true. Otherwise, we return what? False. Awesome. So now we see we're getting an error down here. This error specifically says unreachable statement. If you ever see this, that means up above it, every possibility or every outcome has a return in it. So no matter what if statement it lands in, down here in particularly, it will return from here. So what unreachable statement means is that this line, no matter what happens, no matter how the world turns, it will never be executed. There's no possibility of it allowing it to do that. So we remove it. And now we have officially finished our equal sign. So everyone give themselves a pat on the back. We did this equal sign. So let's go see if it works. Oh gosh, I hope it works. So we have my dog and my same dog, and now we say my dog dot equals my same dog. We run it. Hold your breath. Maybe not, my computer's been slow lately. And it says true. Awesome. All right, what if we change start to Florida? Save that, we run it. Now it's false because it's only comparing the names. So this is that example of the equals method. So going back to it. Again, we are done. So take that deep breath, relax. Take an aspirin if you do have a headache. I have a headache, so I'm sure everyone had fun with this one.
Is that finished for headache, Fancy Head?
Oh, yes, I am sorry. I knew this was going to be a biggie. I was like, oh gosh, they're going to hate me.
I love it. It's awesome. You're good.
All right. So well, I don't have my Slack pulled up. Let me go make sure people don't yell at me. So I'm getting a question. So a search would be practical application of needing to use the dot equals. Absolutely, yes. That would be a very good application of it for sure.
You misspelled finished. Just
oh my gosh, I put the I in the wrong place. Oh, who called me out for that? Frank, you called me out for that. I knew it.
Actually, that's what I was doing at, but I was doing it very jokingly.
Oh my gosh. Okay, I didn't hear that. I'm sorry. Yes. There we go.
So when you need to use equals in multiple places, would you create multiple equals?
So define multiple places.
Well, in this specific case, you were looking at the dog's name, right? What if I need to compare something in a different class?
So this equals exists in the dog class. So this equals method would only be comparing two dogs. If you have a cat class and you want to compare those two cats, You'd have to create a completely new equals method.
Even though it's public?
It's public, but it's public inside of what class?
Dog class.
I got a question.
Exactly.
Okay.
So, I mean, you can't use that because I thought like line 54 was so that you can use that outside of the class.
Line 54. Line 54 or?
Yeah, so like if it's not an actual instance of a dog, then it's false. I mean, the only time you would use that is if you're talking about another class, right?
Oh, you're talking on line 54. Yeah, exactly. So if I come in here and I type in, oh, I have second class up here, which is a completely different kind of class, right? If I have SC in here and I put SC in here, I'm passing in second class into my dog's equal method.
Okay.
If I run this, the world won't burn down or anything, but it's going to come back false because, well, what happens is this got triggered. It came in here and said, second class is not an instance of dog. What the heck are you doing here? Get out.
Right. Okay. So you can still use that outside of the class though, right? Or I mean, like, could you like reference something from another class with that method? I guess that's what you would do.
So here, when you say using it outside of the class, what my mind goes to is you're using dot equals outside of the dog class right now. We're in second class. You're using that dogs dot equals right here.
Okay.
But if I set sc dot equals to sc, well, that's technically true. But essentially what I'm saying is that sc doesn't have an equals method, or second class doesn't have a equals method defined. So technically this would return false here. What I'm trying to get at is that dog has its equal method. We customized it for the dog class, but that's it, only for the dog class.
Okay.
But you're more than welcome to use that dot equals in any other class. We created it so other classes can use it on top of their dog objects or dog instances.
Okay. Yeah, I just misheard you. Sorry.
Okay. Yeah, just making sure. Cool.
Thank you.
Great questions, everybody. Yeah, absolutely. Any last minute questions? Oh, and I don't want to mispronounce your name. I'm really bad at names, and I do completely apologize. Is it Hawa? 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 Okay.
Yes.
Okay. So looking at your question, and I think Alex got to it. Yeah, that's kind of shorthanding the toString method. What was being called out was if we did system.out.println and then just my dog. Well, we're just printing out the object here. And naturally, if you're just printing out the object, it says, okay, they want to print out the object. What are we going to do? It's like, okay, just go to the toString method. That usually solves everybody's problem. Everybody loves the toString method. So that's what the class is doing, is that it's by default going to the toString method and running that. So if we run this, we get back that exact toString that we overtook, that we customized. Yeah, so that's what's happening, is that it totally is using the toString method. You just don't see it because it's automatically in there. Again, it's that default whenever your compiler sees this.
Okay, it only happens when we do have the string method inside of the class.
Well, if we don't have it in there,
okay,
it will just output what? If we don't have a toString here, what's our default? What do we typically print out if we do .toString on an object? What is it again?
Memory address.
Memory address.
Very good, the memory address. So if we run this, we'll get back the memory address.
Oh, right. Okay, thank you.
Yeah, absolutely.
Yeah.
Kyle, can you only use the equals just once? Just like you only use toString once, right? Anyway.
You can only customize it once.
Okay.
So you can only customize it once, but you can use it wherever you want in your code. So we created it once, but we utilized it however many times that you want. You can print out your dog a million times if you wanted to. So create it once, but utilize it or use it millions of times. All right, well, I'm at 7:01. Any final questions I can answer for anybody? Oh, No, it looks like none of those if statements required. Oh, okay. Sorry. Yeah, that is one thing I do want to point out before everyone heads off. This is a statement. What is this magic that I'm doing? I do apologize because I never even explained that. If your if statement only has one line, as in if this if statement is true, it only does one thing, returns true. These are called inline if statements. Magically, there's curly brackets around here. But again, it's only if your if statement does one thing. If I wanted to instead print out something, print line, something and return true, this is not allowed. You have to put curly brackets around this. So I apologize. I did a shorthand programmer thing. So if statements with only doing one thing, such as like returning something or just printing something out, doing a single thing, one line of code, you don't have to put curly brackets around it. If it does more than one thing, you have to put curly brackets around it. Take this with a grain of salt. Don't feel like you have to do it this way. This is just me shorthanding something. And again, I apologize. But for good practice, just keep putting curly brackets around everything with your if statements. But it definitely has nothing to do with override to go into that part of the question. That was just Kyle inline coding magic override. Okay. I am done. I'm out of water and I'm done talking, and I'm sure all of you are bored of my voice. So thank you very much for listening. I hope we again are friends after that equals method magic. Yeah, that's all I have to say about that. But next week, hopefully I'll make it up to you with unit testing. That's gonna be so much fun. All right. So I'm gonna let you all go. Thank you again for joining me. I hope you all did get something out of this. And other than that, have a great weekend. Yeah, stay safe and stay healthy. I'll see everybody back here for next class.
Thank you.
All right, Kyle. Thanks a lot.
Thanks,
Kyle. Thank you, Kyle. Have a good one.
Thank you.
Thank you.
Thank you.
Say bye, everybody. Thanks. Get cookies right now. That sounds good.